All right, everyone. I am here with Noam Slonim. Noam is Principal Investigator of Project Debater at IBM Research. Noam, welcome to the TWiML AI podcast.
Hello, Sam. Thank you for having me.
Hey, I'm really looking forward to digging into our conversation. We're going to focus, of course, on Project Debater and what's new, everything about that project. But before we dive in deep there, I'd love to have you share a little bit about your background and how you came to work in AI.
So I did my PhD at the Hebrew University in Jerusalem at the machine learning lab. This was the late 90s, more or less. I graduated in 2002. And I worked mainly on information theoretic methods for cluster analysis and related algorithms. And the main data that I was considering back then was textual data. And in 2002, I moved to Princeton, New Jersey to do my postdoc. And in 2007, I joined IBM Research. And I worked on various projects. And in 2011, I suggested to work on Project Debater. And this is what I'm doing in the last 10 years or so.
Nice, nice. And was Debater an existing project at that time? How far along was it?
So it has an interesting history because, as I assume you know, we have this tradition in IBM Research of grand challenges in artificial intelligence. So back in the 90s, IBM introduced Deep Blue that was able to defeat Garry Kasparov in chess. And in 2011, IBM introduced Watson that defeated the all-time winners of the TV trivia game Jeopardy. And just a few days after this event, an email was sent to all the thousands of researchers of IBM across the globe asking us what should be the next grand challenge for IBM Research. And I was intrigued by that, so I offered my office mate at the time to brainstorm together. And this is what we did. We sat in the office in Tel Aviv and we raised many different ideas that I cannot share at this point, but these were, mainly strange thoughts. But at some point towards the end of the hour, I don't recall the exact trigger. I suggested this notion of developing a machine that will be able to debate humans, and that this is how we will demonstrate the technology through a full live debate between this envisioned system and an expert human debater. And this sounded better than all the other thoughts that we had at that time. So we decided to submit that, and we submitted the proposal in February 2011, so a little more than 10 years now. And it was a single slide. So basically the guidance were, submit a single slide, don't swamp us with all the gory details. Okay. And this is what we did. And this started a fairly long and thorough review process because obviously there were many, many submissions. And this took about a year. And eventually in February 2012, this proposal, to my surprise, was selected as the next grand challenge for IBM Research. And we started to work just a few months later with a small team that gradually expanded. And we worked for nearly 7 years only on that, just on this mission of developing a machine that will be able to debate humans. And eventually we demonstrated the system for the first time about 2 years ago, in February 2019. Wow. So this is, in a nutshell, this is the history of how this project came to life.
And you describe it as kind of working on this one project over the past, 7 years or so. But the project has resulted in a bunch of different research papers and individual research kind of components. How do you think of the evolution of the project since its inception?
So this is an interesting aspect, I think, of this project, because when we started, we had this, we did what computer scientists often do. We took this big problem and we just decided to break it down into more tangible and more focused and more modular problems. And apparently, to participate in a live debate, you need a lot of capabilities. So this resulted with many, I would say, sub-projects that we needed to run them in synchrony over the years. And the outcome of that was actually a sequence of papers that we started to publish in 2014. So to date, we published, I believe, more than 50 papers in the the immediate suspect conferences like ACL and EMNLP and associated workshops, of course, AAAI as well. But only recently, we really published a paper that describes the system in its entirety. It took us a while, and we actually started to work on that only after the demonstration of the system in San Francisco 2 years ago. And so I would say I would divide that into two. We have these individual papers typically highlighting a particular aspect of the system, which I think are interesting by themselves. Some of them actually touch on problems that were not clearly defined before we even published the paper. And then we have this more recent paper that is very concise and describes the system in its entirety for the first time. And this was published in Nature 2 months ago.
Mm-hmm. We'll dig into those. Before we do, I'm curious, to what degree do you think about what you're building with Debater in the context of the Turing Test, and how does the evolution of the system reflect that?
Yeah, this is an excellent point, because I think we deliberately we explicitly stated that we do not want to pass the Turing test in this project, because I think the test by itself deserves a separate discussion, and I think there are some criticism about whether or not indeed AI researchers should focus on this test. But from our perspective, it was fairly clear that this is not what we are trying to do. On the contrary, actually, it was important to us that the system will present itself as an automatic system. Mm-hmm. And so it will not be mistaken at any point that this is a human being participating in the debate. And regardless, I think it is, at least in terms of the technical approach that we took, the debating style of the system that we developed versus the debating style of a human are pretty distinct. So even if we were trying to pretend as humans, I think it would have been pretty hard in the world of a competitive debate.
Mm-hmm. Can you elaborate on that last point in terms of the debating style?
Yeah. So one perhaps I should explain a little bit what do we mean by a competitive debate, and what were the rules of the competition. So first of all, the debate starts with a motion that defines what we are debating. And in the San Francisco event, it was whether or not the government should subsidize preschool. And there are many considerations around how this motion is being selected, but to be concise, I will just mention that obviously it was never included in the training data of the system, mm-hmm. nor in the development data of the system. So this was taken from a kind of a hidden list of topics. And we are on-site government, so we project debaters support the motion. And we were debating one of the legendary debaters in the history of university debate competitions, Mr. Harish Natarajan. I would say he can be seen as, as the Garry Kasparov of the world of debate. So he was on the opposition side. And we have 4 minutes opening speeches for each side, 4 minutes rebuttal speeches for each side, and 2 minutes closing statements. So all in all, including the pauses, this is close to 25 minutes mm-hmm. of a discussion between man and machine in front of a live audience, mainly journalists from all over the world. It was also broadcasted live in the internet. And the system has two major sources of information in order to perform its goal. One of them is a massive collection of newspaper articles, the LexisNexis corpus. So this is around 400 million articles at the order close to 10 billion sentences. And when the debate starts, the system is using different capabilities. We can talk about these capabilities to pinpoint short pieces of text that satisfy three criteria. They should be relevant to the topic. They should be argumentative in nature. They should argue something about the topic, not just be relevant. And they should support our side of the debate. Mm-hmm. And this is a formidable challenge that we can talk about, but once these short pieces are found, the system is using other capabilities, mainly cluster analysis and some rule-based procedures, in order to glue them together into a compelling narrative. So this is one major source of information of the system. The other very important source of information of the system is a unique collection, kind of a knowledge graph, where we have thousands of nodes that represent, I would say, more principled argumentative elements. And these are written by hand, by humans, by experts. We generated these data over the years. And when the debate starts, the system is navigating in this knowledge graph, so to speak, searching for the most relevant principled arguments, trying to use them in the right timing.
And are those principal arguments in the knowledge graph, is there a subset of the graph that just so happens to be specific to this particular argument, or is it more abstract about argumentation in general?
So these are, I would say, these are more, these arguments reflect principles that people can use during the debate. So let me give you a concrete example. Let's say that we are debating whether or not to ban the sale of alcohol or whether or not to ban organ trade. Mm-hmm. In both cases, the opposition may say, well, if you ban that, you are at the risk of the emergence of a black market, mm-hmm. which by itself has a lot of negative implications. And so the black market argument is a principled one. You can use precisely the same argument in many different debates.
Got it.
One may kind of assume, well, this is not that difficult, right? So it's kind of mm-hmm. a keyword matching thing. If the debate is about banning something, then we should anticipate the black market argument to emerge. Mm-hmm. But of course, this is not the case, because think of a debate about, I like the example of banning internet cookies. Mm-hmm. We're not going to see people standing in street corners selling internet cookies or something like that. So the system really needs to develop, I would say, a more subtle understanding of the nuances of the human language in order to perform well in this task. Then there is rebuttal that we can talk later on. But now coming back to your point, what are the differences in style between this machine and a human? So first of all, the debater has a very good memory, right? It recalls these 400 million articles. And when that pinpoints this specific piece of evidence, it can quote it precisely. It can say, this research published in this year with these numbers and so on and so forth. It will not get confused in the middle. It will not forget what it was planning to say. Mm-hmm. So it is kind of strong in this aspect. It can also plan ahead in terms of the available time and make sure that it will keep up with time. So it has all these properties that I would say are important for the debate. Mm-hmm. And on the other hand, it is much weaker on other aspects of the debate. So first of all, in terms of logic, the logic that we can integrate into the speeches that the system is conveying is fairly limited. So we can identify the general themes that emerge from all the arguments and arrange the arguments accordingly and try to have a compelling flow or something of that sort. But often you see human debaters, they take a point and they can develop the logic of this point throughout the entire speech. And to some extent, they do that because they don't have this body of knowledge that we can rely upon. They have their memory and they have their expertise. So I think this is one important distinction. The place where it starts to be a little bit more similar is when we are starting to use the principled arguments. Actually, in fact, we realize that we need this part of the system after observing how human debaters debate. Because often this is what they do. They have this vast experience of many previous debates. And perhaps I'm simplifying it a little bit, but to my understanding, an important aspect of their skill is really to have this arsenal of principled arguments that they have in their memory, and then they can quickly understand which arguments are relevant to the debate, and then they build a logic around it and start to look for fallacies in the arguments presented by the opponent. So these are very different styles. And when you listen to the debate, you immediately recognize that this is one style and this is the other style. But regardless, as I said, it was important to us. So even we were kind of integrating a little pieces of humor in the debate. And it was also, the subtext was always project debater conveying the message, I'm a machine. I'm not human.
And from the project debater perspective, it's fully hands-off once a debate starts. Besides from, input, output, it's not trying to interpret spoken speech. Is that correct?
So first of all, the system is fully automatic, and it's basically on its own once the debate starts. No human intervention. That's it. So it's exactly as you mentioned. There is this short input phrase. We should subsidize preschool. That's it. So I think there is, it is important to notice the gap between the conciseness of the input and I would say the length and the depth of the output that the system should present. So this is one aspect. Now, when the human debater is presenting, when Harish is presenting his speeches, the system is listening in order to respond accordingly. And this really starts by understanding the words articulated by the human debater. And for that, we use the Watson speech recognition capabilities out of the box. There was a little thing about the British accent of Harish that we needed to handle in kind of just in the last minute, more or less, when we realized that this is a problem. But again, we had capabilities from Watson also to adjust the system to his accent. So the performance in terms of speech recognition were pretty high. But then you need to go beyond the words. You need really to understand the gist of the speech, the claims being stated by Harish. And to that, we used a few techniques that usually rely on the same principle of trying to anticipate in advance what kind of arguments the opposition might use, and then listen to determine whether indeed the opposition were making this argument, and then respond accordingly.
Yeah, when I think about the elements you've described so far, this is overly simplistic, but it sounds like there's a set of kind of general capabilities. An example of that might be when you describe the first part of the system, it sounded a lot like extractive summarization in some ways. And then you've got this knowledge graph that is maybe more domain specific or specific to debater. And I'm wondering, is that one way that you think about the components of the system, kind of general versus specific, or how blurry those lines are?
They are blurry to some extent, but I think it is a fair way to try and grasp what the system is doing. So first of all, it is extractive. It is not abstractive. It will not start to say things that, by itself. It will take pieces of text from various places. And the rationale behind that was that if you're going to present this system in a live event in front of the entire world, you need to be careful about what the system might say. So as we know, an abstractive summarization technique or a generative network or something like that, it can say anything. So we wanted to avoid this, I would say, subtle situations. But by the way, even in extractive approach, you may reach points that are kind of risky. The issue is that sometimes in a very credible resource, they will quote a ridiculous claim by someone else just to counter this claim.
Right.
And the system needs somehow to figure this out, because these claims could be outrageous. So if you are completely naive and the system is looking for these short pieces of text that I mentioned earlier, it may find a sentence, the sentence is relevant, argumentative, then it can cut a short piece out of this sentence that represents the claim. And if it is not careful enough, the claim could be ridiculous. And we needed to add some safety mechanisms in order to at least simple safety mechanisms in order to avoid a situation like that. But going back to your point, the system is extractive in nature. But when we compare that to extractive summarization, let's think about the summarization challenge that we have. Essentially, we get this query, and we need to summarize all the arguments out of 10 billion sentences. So this is not summarizing one document or 50 documents.
Right.
This is kind of summarizing the entire corpus. And another distinction is that the system has a stance. So we need to automatically identify each argument if it supports our opinion or not, which usually is not considered in, I would say, in standard summarization algorithms.
And is the system, during its training phase, is it attempting to parse out the argument of or the stance of a given piece of input data, or is it more just ingesting the text and then later during a debate identifying arguments that may support its points?
So the system is preparing things in advance.
Okay.
So the entire material it is going to use during the debate, the system is preparing that in advance. And it actually prepares more material than what will be used eventually in the debate. And then during the debate, the system can decide in a dynamic manner to say, okay, so the opening speech is kind of written in advance because we are opening the debate and we haven't heard anything yet. But once the human debater is starting to provide her or his input, then the system can dynamically decide, whether to skip some arguments and give more room for rebuttal or things like that.
And just to elaborate on this point quickly, can you discuss the relationship between the system's preparation and training?
Yeah. So this was, I think, another interesting aspect of this project, because we had all these different components. So just as an example, we had a component, and these are actually available today, freely available for research purposes. We can touch on that later on. But just to give you two examples, one component was really a component that the focus of that was to detect pieces of evidence in the massive corpus, and this component has its own training data, development data, and test data. So training data for this component could be in the form of, eventually it became very, very large. We invested a lot in how to annotate data in an efficient manner by the crowd, but eventually we annotated, I would say, around 200,000 sentences in LexisNexis corpus as either containing evidence which is relevant to a particular debate topic. So this was done with respect to, 100, 200 different debate topics. Or the sentence seems to be relevant, but it is not representing evidence that you can use during the debate. And the distinctions could be, quite subtle. So imagine that, one example that we gave, you have a debate about whether or not Valentine's Day, we should keep it or not.
Yeah.
And then the system is fighting these two sentences. One of them is saying, well, there was a survey running in Canada, and people said that basically this is a waste of time and money, and we should forget about it. That's fine. You can say that. Then there is another sentence saying, well, we had a survey in the US, and people said that if they're going to break up with their partner, they will do it just before Valentine's Day, so they will spare the money on buying a present for Valentine's Day. So this is kind of perhaps a useful piece of information to know, but you're not going to use that during the debate. Now, both sentences are very similar in structure. They mention the word survey, they mention numbers, they mention statistics. So making a distinction between these two is fairly challenging. And we needed to reach very high accuracy in order to perform well. So this is one module. Then there is another module saying, can we automatically identify whether this piece of evidence support our position or support the position of Harish? So we refer to that as pro-con analysis. And this is also a service which today we make available, freely available for research purposes. And again, this has its own training data and development data and test data because the target function is different. And now these need to be somehow synchronized because, and this was a little bit challenging because, at some point we have this capability of evidence detection, and it can find pieces of evidence of a particular characteristic. And then the team working on pro-con analysis are considering these data, and they make progress. And 3 months later, they have very good results. But during these 3 months, the other team also made progress. And now the evidence that they generate is actually quite different. So this was a little bit tricky to keep everybody in synchrony.
Sounds a bit like a ML ops type of a problem where you've got different versions of components floating around and you need to.
Exactly. And sometimes the component was, in this kind of project, we were very focused on the goal, on what we need to accomplish. And this was, in my opinion, this was very useful because I sometimes think of that as a lighthouse in the dark. You are on this ship in the ocean and the waves are coming and this is night, but you have this lighthouse far away and you know exactly where you need to go. And this is very helpful in terms of taking decisions. And for example, at some point we realized that we should develop the capability of entity linking, or more specifically, Wikification. That is to identify in each sentence what are the Wikipedia concepts being mentioned in this sentence. And the reason was that we realized that this could be very useful. For example, if we are debating whether autonomous cars will bring more harm than good, there are many ways to refer to the concept of autonomous cars. You can say autonomous cars, and you can say driverless automobiles, and there are like dozens of ways by which you refer to the same concept. So if you have this utility that can automatically identify that this Wikipedia concept was mentioned in the sentence, you are basically vastly expanding the amount of data that you're going to consider for the debate. But the challenge was, how do you Wikify 10 billion sentences? Mm-hmm. It's not about Wikify, and you want to do that several times because perhaps you are improving the algorithm and so on. And the algorithms that were out there were simply too heavy for us to run. So we developed
to make sure I'm on the same page. When you say Wikification, are you talking about cross-linking entities within the phrases in your corpus to actual Wikipedia pages, or kind of cross-linking? Okay, the format.
Yeah, just saying, in this sentence, these are the Wikipedia concept that is, we're just, you can think of that as sending pointers from the sentence to the relevant Wikipedia pages. But we needed an algorithm that, even with heavy computational resources, if we were using algorithms out there, it took us like 2 months to complete just a single run. And this was too much. So we needed actually now to develop this capability. And this means that we needed to develop our own evaluation data. And this meant that actually we needed to go into the annotation process of, how do you train crowd workers to identify Wikipedia concepts in a sentence. This is a story by itself. But we generated very nice benchmark data sets for training and for development and for testing, and converged to a very simple and highly efficient algorithm that was performing very well. And obviously we share these results in a couple of papers. And also this is an example of, I would say, a more basic NLP capability which is available today. So if you want to so if you are a researcher with interest in this field of entity linking, and you have your own data and you would like to try it, you can just go ahead and use this service, which is available, and it runs extremely fast. So we were able to Wikify 10 billion sentences in like less than 48 hours. And actually the performance of this algorithm, in spite of its simplicity, are very good. And this was interesting. So in some cases, we needed actually to resort to solving relatively basic NLP problems simply because we needed the capability, and nothing that satisfied the requirements was available.
You talked a little bit about performance in kind of relative performance of this Wikification module. I'm curious how you think about performance and evaluation and metrics and baselines across the various components and the broader collective debater system.
Yeah, so when we evaluated in individual components, we used the standard paradigm of supervised learning. This was kind of, follow the protocol. You have a training data, development data, you have test data, do the evaluation, see that you improve over time. We needed to reach extremely high precision, so the system as a whole was very much precision oriented. But the evaluation, we didn't need to invent anything new. We needed just to, in terms of evaluation, we needed to be very rigorous in terms of benchmark data sets development and things like that. But when you talk about evaluating the system as a whole, this is a different story. And this is actually one of the main points that we made in this recent paper that describes the entire system, because it is completely unclear how to, first of all, even when you consider a single debate, it's not that clear how to score the system. Its debate can last for, in our format, can last for 25 minutes, and also, the way it works in a live event is that people vote before the debate starts on their position, and then they vote again after the debate ends. And then the winning side is declared as the side who was able to pull more votes to his position. But this is a very complicated production, because you need audience and you need a human debater, and the audience need to be unbiased, and sometimes the vote before the debate start is extremely biased. So this was pretty challenging, and eventually, and also another requirement when you want to publish a paper is to compare your system to other systems.
Right.
But the point was, there was no other system capable of doing a debate. So how do you kind of get a point of reference, even if you succeed to score the system? So what we did in this recent paper was to approach that in 2 stages. First of all, we said, look, to participate in a debate, you must have an opening speech. Okay, this is if you cannot articulate a good opening speech, don't go to the debate, right? And an opening speech is something that other systems can do. So you can take a summarization technique and use some queries in order to bring relevant documents, and the summarization technique will summarize and generate an opening speech. You can use a GPT-like system. So we really wanted to compare to GPT-3. Unfortunately, we didn't get access, so we resorted to compare to GPT-2.
Okay.
And again, GPT-2 fine-tuned for this particular task, fine-tuned to articulate arguments that are relevant to the topic, or to articulate a whole speech and so on. So this was a very challenging comparison, and we didn't know what would be the outcome, because when we started the project, we started in 2012. Okay, so deep learning in NLP was not really there. Okay, GPT-2, I think it came out in 2019 or something like that, or 2020, and we started this comparison in 2020 with this, major and very prominent technique that just came out, and we were very curious to see what will happen. And we also fine-tuned it over thousands, tens of thousands of arguments, to give it a best shot. And then you send the speeches to the crowd and ask them to give it a score between 1 to 5. You can ask them how well the speaker is performing in this opening speech. And you can say, the speaker is performing well, and you can answer between 1 to 5, strongly disagree or strongly agree.
Yeah.
And then you average over 80 topics, because a live debate is one debate. We wanted the results, to be statistically meaningful. And also we compared that to expert human debaters, which was an upper bound on the same topics. And the scores were pretty interesting. So debater system came very close to expert human debaters. I think the average score of debater was around 4, and human debaters were around 4.2. And GPT-2, I think, made it to 3.4 or something like that. And it was the best amongst several other techniques that we tried for the opening speech. Then we did another thing, to evaluate the whole debate, and this was by sending human evaluators 3 speeches: the opening speech by our system, a response speech by a human, and then the response speech by our system. And again, asking them to give us a score between 1 to 5. And again, we saw that the scores are pretty good, at the order of 4, to the question of whether the system is performing well in the debate. Okay. So we were very, I would say this was a kind of a tense point, because we really didn't know. It was past the demonstration in San Francisco, and now we started to do this systematic evaluation. We really didn't know what we're going to get in the results, but the results were pretty good.
How many end-to-end kind of full-on debates has the system performed?
Oh, this is an interesting question. I would say it's probably close to 100.
Okay.
But public debates out of IBM, I would say it's around 5.
Okay.
So most of the debates were internally, and we started the first live debates in 2016. After more or less 4 years of work, we felt that that's it. We must jump into the water, and we started the first live debates. And this was the system was completely clueless. I remember many team members vividly remember this. One of the first debates we had, it was whether or not physical education should be compulsory, and the system started to talk about sex education. And the human debater was trying to bring it back to the topic, and the system was just drifting away. And this was very amusing for some people in the audience, and very disturbing for some other people in the audience, depending on your perspective, I guess. But I would say what was interesting to see was that, in 2016, it was at the level of a toddler. It was not making a lot of sense. It was making arguments in favor of the opposition, drifting away, and so on. 3 years later, it was at the level of a strong university debater. So the way I like to see it, we made it from kindergarten to university in 3 years, which is pretty good.
So you've got this, set of 100 debates. The debates are evaluated by having human evaluators or audience members rate their perspective on the topic before and after the debate. Does that then become a source of training data that you can use to have the machine learn from its own performance, or would you need a lot more debates in order for that?
A lot more. We only used it for evaluation and to keep track of where we are in terms of the performance of the system over time. So we will have some kind of a quantitative assessment before we go out and present it to the board. But again, we were discussing within the team, is it possible to do something like that using an end-to-end system? Because obviously this is not an end-to-end system, right? We have these components, we have this orchestrator that is, we actually in the paper, we use this term of composite artificial intelligence, because we think of it as like in composition in music, where basically you need to orchestrate all these different capabilities into a single cognitive activity, which is debating. And the question emerged, can you do that using an end-to-end system? And how much data you will need for that? And to be fair, from my perspective, I don't see how this can be done in an end-to-end manner. Even if you have many, many debates, maybe this will show up, in the upcoming years. But I think this is one of these tasks that actually should be handled by decomposing the problem into more tangible problems.
Mm-hmm. You alluded to the fact that when you first started this project, deep learning was at its infancy, and certainly we've seen natural language processing evolve pretty dramatically over the past several years with the emergence of large language models. How, both from a technology perspective as well as from a kind of managing a research project perspective, how do you deal with that change that's happening in parallel for such a big problem?
This actually has an interesting history in the project, because when we started, deep learning was not really dominant in the NLP world. So we started with feature engineering and logistic regressions for claim detection and evidence detection and so on. Mm-hmm. And then I admit I was very suspicious about this deep learning trend, and not to say annoyed by it when it started to show up, and said, look, I don't like that, but it became larger and larger, and more team members said, look, we cannot ignore that.
Yeah.
And I said, fine, that's okay, but you need to show me numbers. We're not going to do that just because everybody else are doing that. Mm-hmm. If you can show me on the benchmark data sets that we have that this is performing better or even comparable to what we already have, that's fine. Now I'm willing to switch, but the burden of proof is on you. And we had this team of researchers that started to look into that more and more. And I was starting to be impatient, to be fair, because it took time and the results were not that good. We had actually better results. But in a couple of months, at some point they told me, look, we need 2 more weeks. And I said, fine, okay, if you think that you can really improve in 2 weeks, fine, go ahead. And they did it, and they showed a very nice result, actually slightly better than what we had by then.
What specific problem was this?
It was on claim detection. It was on detecting claims, and this was, I think, sometime during 2015.
Okay.
And this was very interesting to see, because the proof is in the numbers. You can have your own criticism about whether this is good or bad for science, but if this team in just a couple of months outperforms their own work that they did for, for 2 or more years, you cannot ignore that. And then we started the shift. So we started to use deep learning more and more. And in 2016, I would say 3 things happened. We started to move to deep learning. We started to consider much larger data, the LexisNexis corpus. Up to that point, we were considering only Wikipedia. And we started to annotate data with the crowd. And the boost in terms of the result was remarkable. So at the end of 2015, these were the numbers that we had for claim detection and for evidence detection. The precision in the top 40 predictions was 25%, 30%. It's a very tough problem, and this was very disturbing. By the end of 2016, we were above 70%. And today, actually, if you consider the evidence detection module that we have with these APIs that we release, where we use BERT fine-tuned over large data and so on, we get more than 95% accuracy over the top 40 predictions, averaged over 100 topics, which is really remarkable in my opinion.
Can you speak a little bit to the kind of methodologies that you evolved around annotation and taking advantage of crowd workers to deliver that annotation?
Yes, this was another dominant issue that we needed to address, because we had many problems and we needed to collect annotate data for many different challenges. And we started with an in-house team of annotators that we trained very carefully. So we had this team, and they did tremendous work, but eventually it doesn't scale.
Yeah.
So we needed to move to the crowd. We used it was called Crowdflower at the time. Then it was called Figure 8. Today it is called Appen. But we developed a lot of expertise in working with the crowd annotators. And one interesting transition was that when we worked with the in-house annotators at the beginning, we were very pedantic, very, very careful about how to define evidence, how to define claim. We had this book that we wrote with all the guidelines and all the examples and all that. So the first data that we developed was very precise, but also very small. It contained a few, I would say 500 Wikipedia pages completely annotated by these annotators, which was a tremendous effort, but this was too small. And when you move to the crowd, you cannot show them such elaborated guidelines. They're not going to do that. They're not going to read that. So the focus was really, how do you articulate in just a couple of paragraphs, maybe 3 paragraphs, what you mean by evidence and what you mean by claim. Give them 2 or 3 clear examples and they should be good to go. And then you need to add a lot of layers of, I would say, monitoring the quality of the work of each annotator and removing those that are doing poor job and rewarding those that are doing good job. And this is how we eventually were able to annotate large enough data.
And are you currently using a quorum type of approach to annotation, where you get the multiple annotations?
Oh, of course.
You do that.
Of course, each sentence, when I said that we annotated 2,000 sentences, I meant each sentence was considered by between 10 to 15 people. So this was, we invested a lot in that, and many of the data sets that we developed, we shared with the community. So LexisNexis, we don't have the terms of the data is that we cannot share that. But Wikipedia data and other data sets we are sharing, and some of the data sets are very interesting. For example, over the years, we recorded, I think, close to 3,000 debate speeches by human debaters. They were debating it was very interesting. It's like you play chess by mail, right? I send you an envelope with my move, and then this was, back in the days, and then you open the letter and you read the move, and then you do your move and you send me a letter. So we had debates in this format. Basically, we had a team of debaters, and they were receiving a topic, and the guidance were, you need to prepare for 10 minutes, and then you need to record yourself with the opening speech.
Yeah.
And then this speech is being sent to another debater. You never meet him. Okay, this is being sent to someone else. And his guidance is really to listen to the speech and then prepare a rebuttal. And then the rebuttal is going to perhaps to a third debater who is listening to the first two speeches and responding. So in this way, we collected, I would say, around 3,000 debate speeches. And we also shared that in a recent paper last year with the community, where we did some analysis over these data. So I really encourage all the listeners, I would say, to do two things. First of all, to visit the Project Debater website and consider all the data sets that we released over the years. And moreover, to try many of the capabilities that we developed. They are available for free for academic research. So it could be Wikification that I mentioned. It could be claim detection, evidence detection, pro-con analysis, argument quality that we didn't have time to touch, and even more advanced capabilities that we are developing over the last 2 years, like key point analysis and narrative generation. So all these are also text clustering. All these are freely available. So I assume you will put the link on the podcast, and everybody can go there. And if you are a researcher in the field doing academic research, I encourage people to give it a shot.
And there are about a dozen of these APIs that are accessible for different subproblems?
Yes, we have about a dozen. We're going to give a tutorial in ACL on that, and also on HKI. And we are excited to see what people will do with that.
Awesome. We'll definitely provide the link to that in the show notes page. So check that out if you're listening to this and interested in learning more. To kind of wrap us up, I'm wondering, in this 10 years of experience from initial idea to today, what your experience with this project has kind of taught you or left you with in thinking about the broader development of AI?
So I would say that the first answer is actually not about AI, it's about people. I think it's really about the people that you work with. And I feel truly fortunate to be able to work with an amazing team of researchers that are not only top researchers dedicated to their mission, but they're simply people that are fun to work with. So I think this is the most important aspect, to spend your time with people that you like and that you have fun to work with. And in terms of AI, I think, we started this conversation by mentioning earlier grand challenges in artificial intelligence. And grand challenges in AI are really there from day one. So back in the 50s, Arthur Samuels, who was in IBM, actually the person who coined the term machine learning, he was working on developing a software that can play checkers. And he spent decades on that. Today, it looks kind of trivial, but he spent decades on that. And when he succeeded, when it was performing very well, this was a sensation. People were amazed by that. And then Jerry Tesoro, one of the founders of reinforcement learning, also still working in IBM Research, worked on backgammon and developed fantastic software. This was in the late 80s, early 90s, that was able to play backgammon and using, I would say, at least conceptually, techniques that are not very different from what you see in recent years in AlphaGo. And in the 90s, there was chess, and more recently AlphaGo by DeepMind. But I think all these board games, while they were extremely instrumental in pushing the boundaries of AI, they still lie in what I refer to as the comfort zone of artificial intelligence. And there are several reasons to that. I will touch on one. When a board game is done, we know who won the game.
Mm-hmm.
And this has very important implications, because this means that we can have many versions of the system. We can get the signal from each game. So you can hold millions variants of the system. They play against each other. After each game is done, you know who won the game. You can improve by that. Mm-hmm. When a debate is done, we do not necessarily know who won the debate. It's not even clear how to define that. So you don't have this pass. Mm-hmm. And you need to follow and use other paradigms. So I would say debater is certainly out of the comfort zone of artificial intelligence. It's in a different territory where humans are actually still better. And from my perspective, I think this is good news, because this means that we still have many open questions to answer.
Awesome. Awesome. Well, Noam, thanks so much for taking the time to share a bit about what you're working on and IBM Debater. Very, very interesting project with a very broad scope, and it's been nice for me to have the opportunity to follow it over the years.
Thank you very much, Sam. It was a real pleasure.
Thank you.